Uh, Hello everyone. Today we are going to learn what is Docker. So today's agenda will be, before we jump directly into the Docker, we will understand what is virtualization and containerization. After then we'll understand what is a Docker exactly and its architecture. We'll learn something basic commands for the Docker, and we'll learn how we can build a Docker image. So let's start. Before we understand what is virtualization, we should understand what is the process first. So the process is nothing but program in its execution. But only program is not sufficient to run the process, right? So let's take an example. If we are running one of the Java program, what we require? Java and JDK installed in our system, right? So the definition will be program plus execution with its libraries and dependencies is nothing but the process. So we will see what is means before we hit into the virtualization, what was the system, means what was the architecture we were following. So we used to have one server, let's say, and in that server we used to run many processes such as, let's say, if, Java 8, Java 11, Node 11, Python. So many processes we used to run in the same system. So what happens whenever uh, there is a whenever there is a need to install any one of the, let's say if I want to run Java 12 again on that same system, so it was giving a problem with respect to the library dependencies and its dependent packages. That's how the problem we started with the one single host server machine. Apart from that, for example, if one of the service or maybe one of the process starts utilizing many resources at a time, other processes used to get killed. Means the resource cover, so they had to compromise their resources as well. So to avoid that, virtualization came into the picture. So what we did in the virtualization, we had one our physical machine. Uh, on top of that, we have our one operating system, that is one kernel, and we have one hypervisor, that is virtual machine. You must have heard about VirtualBox, VMware, etc. So that is nothing but the hypervisor, which helps us to learn many VirtualBox at a time. So what we did, we added hypervisor. On top of that, we install one of the virtual machines, many virtual machines. So each virtual machine has its own space, own libraries, and if, let's say, if I want to learn Java 8 application on that virtual machine, it will be the only one application will be running on that system. So same on, let's say, if I want to run the any Python or Node applications, I'll create another virtual machine or virtual VM, and then I can install whatever dependencies required for this. And within that space only, that given resources, we started using our resources. So everything is working fine in this architecture. But again, the problem started with uh, the resource optimization. So what happened whenever let's say if I want to install a virtual VM on Windows, means with the Windows machine. So the very first thing is the Windows is not a open source operating system; it is a paid one. So I had to start, means I had to pay for that OS operating system first. After then, there is a maintenance charges also get added. Plus, to install that guest operating system, I required a dedicated resources. Means I had to provide dedicated resources for that. So on top of that, then I'll install my application. So the thing is, for the guest OS operating system, it itself required so many. It required given resources, and resources such as specific CPU and the RAM. If we talk about Ubuntu, it requires at least I think 2 GB of RAM and one CPU core available for the operating system to run. So again, the resource and maintenance issues started coming here as well. So to avoid this problem, containerization came into the picture. So previously what we have our physical machine, we have operating system. On top of that, we are running hypervisor, and on top of that, we are running multiple VMs. So So we remove this guest OS dependency over here, and we directly started running our application as a process in container architecture. So what we have here is on the right side window, you can see that we have infrastructure, we have installed OS, we have one container engine. So there are many container engine available in the market, and on top of that we are running only containers. So let's see, if I'm running a Java process, the only Java application or dependency will available in this will be available in this particular container. So that's how we have overcome the problems that we were getting with respect to the resources, the maintenance, and as well as overhead to the operating system. So the containers are nothing but OS level virtualization method, which is nothing but a one single isolated process. It runs with the help of control group and namespaces. The containers are nothing but a lightweight TVM. Means it has only one simple parent process. Let's say if we're running only one Java or maybe one Python process or maybe one Java process, then it might be only that only parent process will be running over there. If you kill that particular process, your container will get killed. So a container provides a software package environment. So software package environment is nothing but whatever required to run your process, it will be packaged into that container already, and you can build once that container and run everywhere. Means with the help of containers you can build the image, and once you build the image, you just share it to the in the form of repository or the registries, and you can use that container to any system anywhere and it will run the same. So that's the containers. Now we will come to the Docker. So Docker is nothing. So what is a Docker? Docker is a product which provides us a OS level virtualization, that is containerization. So if we go to the definition of it, the Docker is a set of platform that use OS level virtualization to deliver software in packages called containers. So we already have seen the Docker containers definition. It is a similar. So Docker is a tool which provides containerization in our system. So Docker is written in the Go programming language, and and Docker is using a client server architecture. So let's see the client server architecture of the Docker. So what we have here is, so we have a client, we have a Docker host, and we have a registry. So client is nothing but it will run the Docker commands, and that Docker commands will request to the Docker daemon. Means it is nothing but the API request to the Docker daemon. Then Docker daemon is nothing but managing all the containers, images, networks, volumes with whatever whatever system, whatever container requires to run. So it manages all the containers and images. So if you run the Docker build command or maybe Docker run, the API request sends to the Docker daemon. A Docker daemon manages all the APIs and give the response to the client with respect to running that particular image or maybe that running that particular container. So let's say if we start Docker command, so registry is nothing but a repository where we can store all our Docker images. So whenever Docker pull command runs, Docker daemon will fetch image from the Docker registry or any other registry that we have defined, and it will start fetching from, and it will give an output and list out that images in the local itself. So this is about the Docker architecture. So we will see now Docker installation. So I have used this. So I am using Ubuntu system in my Ubuntu system that I have created in AWS. So to install this Docker, you can directly go to the Docker website. Based on the system that you are using, you can directly install Docker engine for your system. So we will see what are the Docker basic commands. So the very first command is Docker images. So we run the image, we run the container out of the image. So what Docker will do, Docker will fetch the images from the Docker registry that we have mentioned before, and you can run that images with respect to that. So let's see. So as I said that I have installed, I have created one of the AWS machine. I'll just connect to that. So if I run docker images command, you can see these are the images that I have pulled. If I want to pull one of, let's, MySQL image, so I'll just simply run the command docker pull, and I'll just put the MySQL. So it will just use the latest image that is available for the MySQL. Now if you again run docker images, you can see that there are 3 images now there. The one is MySQL that I have recently installed. The second command is nothing but docker ps. So docker ps is nothing but the it will give an output of exact running containers. So how many the containers has been executed and are still running, you will get the output by using docker ps command. So I have already created one container.
Priyanka,
So,
can you little bit zoom in?
okay, sure. Is it okay now?
Yes, yes.
Thank you. So if you see that earlier I am using already, I have already created one container, so it is giving me this output. If I want to see what all container has been run and got exited, so you can see that this output, like I created another one container nothing for the simple hello world command, and it executed 59 minutes ago. So you can see this the container id from which image that you have built, the command, the basic or maybe we can say that the process command that you have executed, when it got created, the status of that, if it is forwarded to the edit port, and the name of the container. So you can even define your name by whenever you create a container. Second thing is docker pull. So we have already seen the docker pull command, like you can fetch as many as images from the docker registry itself, and you can run that in your system. So docker start and docker stop. So I already have created this container, right? So what I'll do, I'll just stop this container running, and I'll provide the container id to it. So what will happen, that container will stop, and if you run the docker ps command again, you will see there are no containers. If you see, if you check all the containers at a time, you can see that it exited 9 seconds ago. So to start that container again, what I'll do, I'll just pass I'll just change stop command to the start, and I'll pass the container id to it. And if you run the docker ps again, you will see that container is still it started executing over here. So these are the basic commands of the docker. Now we'll see what are the docker images. So to understand docker images, let's say this is the nginx container that I have created. Okay, and what I'll do, I'll just execute into this container. I'll just touch let's say I'll just create one file. I will input some data to it. The test.txt, and you can see the file may have created. And what I'll do, I'll just delete that container. I have to stop the container first. I'll remove this container. Now you can see that there is only one container in my system, and now I'll again run docker that particular container that I have created in the detached mode. So docker run command is to run the docker image. So docker run -d, the name of the image that you are using. So I am using the Nginx image. If you see the all output, you can see that there is a new container ID has been created, and if I exit into that particular container again, the newly created one, you can see that the file I have created will not be here because the container does not maintain any of the changes that you have made. So in order to persist your changes that you have created with respect to your applications, you have to maintain the means you have to create a snapshot of your container as well. So what I'll do is I'll just create another test.txt file. I'll echo output again. I'll just exit from here and I'll create Docker snapshot from which container? This container. Okay. So we'll also snapshot it in Docker shell and the container ID. And okay.
Hello, Priyanka.
Hello. Hello.
Yeah, Priyanka.
Okay. Am I audible?
Yeah, you are audible, but screen seems to be freezed.
Okay, just let me check again.
Now it is working.
Keep moving.
Yeah, yeah.
So I'll just start. I think I got it missed. So we were checking that we had created a Docker in our Docker container. We have created one of the file in our Docker container, and now what we will do is we'll just save this container so that our file will not get missed, and create an image out of that container. So to create image from that container, what we have to do is we have to create. So we have one command called as docker commit snapshot. You can see that. I'll just provide from which container ID that I have to create, and the name of the container is Nginx text. So you can see that I had created one of the Docker image. If I run Docker images command, you will see the Nginx text has been created. Now, if I run this Docker Nginx text command, let's say detachable mode, you will see that Docker PS, the Nginx text has been created, and Docker PS, and if you again exit into that container, not this is the container ID. So you see that text file is present over here. So every time you want to make some changes to the containers, what you have to do is you have to just run the commands into the containers, and you have to commit it to the one of the Docker registry as a Docker image, and run again the image out of that. Run the container again from image out of that. So this is a cycle that you have created. But let's say if you want to make thousands of changes at the same system, means at the same container, and you are, so it is not feasible for us to run command after every changes, run commit command after every changes. So in order to avoid this problem, Dockerfile came into the picture. So so you can, so this is the example of Dockerfile. Now you can see that. So how we can start from a Docker file? We have to define the base image from where we have to from where we are going to the base image is nothing but from where we are just going to install our instructions. So it can be anything like right as of now this is the example of the node npm node.js code. So if you see, I have used node colon 18 alpine image for that. So you have to mention so the keyword for to pull the image to the pull the base image is nothing but the from. So work directory is nothing but your parent directory. Like whenever we exec into any VM machine, we directly exec into the home. So if you define the work directory for that, it will the Docker will create the work directory for you, and will switch to the slash app as a directory. To copy from machine means to copy any files from your host machine to the images. What we do, we have a add and copy commands to the for the Docker file. So from using add or copy, you have to provide a host path and then destination path to the copy. Just like we export environment variables in the Linux machines, similarly you can define the environment variables in the Docker file as well, and you can use enter in your code. So you can see that env is equals to key comma value. So this is the nothing but environment name, and this is the value. So to run the run or execute commands, like just like a shell program, or maybe anything that you want to install, or any binary that you want to execute. So run will help you to run all to execute all your shell commands. This exposes something, but let's say if your service or your container is running on some of the port, and you want to expose that port to the external world. So this is just for the documentation purpose. So you can define the port number over here. So anyone who is going to run that container again, what he will do, he will just check which port is exposed to the outside world, that is 9090, and whenever he run the Docker commands or whenever he run the Docker container, he will use this port number to expose it. And now again we have command and the entry point. So you can either give CMD, or you can either give the entry point. You can give both of the instruction at the same time, but command will be the will be passed as a arguments to the entry point. And in front of that you have to provide like from which process it should get started. Example, if you are running let's say any Python program, so Python program and the file of the Python that you are running, this is how you are going to provide the executable files and its arguments or the parameters in the form of the array. This is the example of the Docker file. So let's build one of the Docker file over here. So now I am outside inside the container. I just give it. So you have to create a Docker file with the file name. As of now, over here, I'm going to use nginx as my base command, as my base image. My work directory is nothing but where my all HTML files are here. Now what I will do, so for the nginx, the home page is always welcome to nginx. So as I was already running one of my containers, you can see that okay, this is my public DNS of my machine, and container was already running over here. So I'll just run this. You can see this is the home page of the nginx. So it is directly loading it from the HTML. So I want to replace this page uh, with my own HTML page. So what I'll do, I'll just copy index.html to HTML page over here. We have to check path first. That's it. So this is the 3 commands that I'm going to run. Now I have to create a index.html here, where I'll just define one header, that is welcome to Docker. Now to build image out of a Docker file, we have a command called as docker build. If you want to give a name of that particular image, the command, the flag we have used is -t. So I'll just give a nginx test image. Now you can provide a tag as well. If you don't provide a tag, Docker will add latest as your tag. I'll just update this as 1.0.0, and I have to provide a path and the context. So to provide the context, you have to context as in where all your in whatever files or maybe whatever files or directory that you need to build your Docker file. This is called as the context. So now my all index.html and Docker file is in the same system only. So I'll just provide dot over here, and -if is nothing but to provide a path of the Docker file. But I'm not going to use this flag because my Docker file is same as directory of context. So I'll just skip this and I'll just start building the image. And you can see that Docker build has been finished. And if you run again Docker images command, this is nothing but the nginx test image that you can see. Now what I will do, I'll just run Docker run command again. So you can see that the nginx is running on the port 80 in the desktop itself. Right. So what I'll do, I just so there are some processes already running, and to check the output of that nginx text, what I'll do, I'll just delete the previous container that I was using. So to run the command, okay, I have to stop and then run. Now I'll just expose this container. I have to remove all of them. Now I have removed all the containers which is running for the Nginx image. I'll create another one for my the one that I created uh, from the Docker file. This one. So I'll just start running docker run -it. So this is going to be the detachable node. I'm going to expose this port at port 8080. I'll just start executing the command. Sorry, I did some typo mistake. Sorry, you have to provide a -p as a to export to the port. It's a test image, that's why. Okay, its tag is version 1.0, so I forgot to mention tag. If you see docker ps command, you can see that the container is up. Now if I again reload it to the Nginx, you can see that the whatever changes that I have made, welcome to Docker, it has appeared here. So that's how you can build a image, build the image from the Docker file. And so basically what we have done, so we have created a Docker file. We run the docker build command. What docker build command will do, it creates one images out of that. So it tag it again. It run the whatever instruction that you have provided. It will run that instruction first. So to run that instruction, it will create the containers. It will in background, just previously like we have used a docker commit command. In background, it will use a docker commit command. It will again build the image. It will go to the next. It will again read the file, docker file. It will read the next. What we can see. Next instruction. Again, run the command in the containers, and then it will come into the docker images. And then what we can do is, with the help of this, you can even means till the end of the file, you can form a fully fledged docker images. And you can even push that images to the docker registry. That is, docker is the public docker repository or docker registry. You can say you can even have your own private docker registry as well. You can even, once you push, let's say some other person came, he can even pull that image and run his container out of that image. You can even save this particular image as a backup, means as a in the form of tar file, or by using docker save command. And using docker import, you can even load that particular tar file again in the form of the images. So that's how you can build the image in the docker. That's it.